Hey, hey, hey. So today we are going to be talking about using studies in statistics wisely and cause and effect challenges. So if we turn to page 18 of our notes, we're going to talk about the scope of inference in the statistical study. Now remember, the whole premise behind statistics is that you are going to take some samples. Make sure you try to eliminate bias as much as you can. Get a large enough sample size, and we know if that's true of those samples, we can make conjecture or infer that it is going to be true of the entire population. Okay, so when it comes to random samples, okay, it allows inference about the population, just like I said. But when it comes to random assignment of individuals to groups, it permits us to determine cause and effect. So, in other words, if I have to check to see if a particular medication works better than your existing medication. So let's say a blood pressure medication, and there's a new drug out from Yarborough Pharmaceuticals, and I want to say that I want you to test my drug. It's going to be less expensive, and it's going to be better for you. Well, when I come up with my treatment groups, I can't just say I'm going to pick these five and these five. Let's say the first five are from the same area, have the exact same job type. Okay, the other five are again from a different area and they have a higher stress job, but they're all equal. Well, there's no random assignment there because if you heard the commonality, you've got groups of people together that live in the same type of area, and then you've got groups of people together that have the same type of job. So how is that randomly assigned to see if Yarborough Pharmaceuticals' new blood pressure medication is really going to work? It's not. So we have to assign them into individual groups, assign individuals into the groups, and once I do that, then I can go, okay, there's cause and effect. I know that this works. That's what clinical trials do. Another thing that I have to make sure to consider lack of realism in an experiment. Okay, it prevents us from getting generalized results. I remember there was a CSI Miami episode in which, this is going to sound gory, but someone was stabbed, and they were trying to figure out with what type of knife the person was stabbed with. So what they did is they took some a mold that was liquid and poured it into the wound of the person that unfortunately had lost their life due to the stabbing. And then the mold, once it hardened, showed the type of knife the person was stabbed with. Lack of realism. It doesn't work that way. And even if they did it with thousands and thousands of corpses that had been, unfortunately stabbed, is that a realistic experiment? Is that, even if you did get some type of results, which you can't imagine, yeah, the tissue has hardened, they're in rigor, but the reality is the lack of realism to that. Will that give you, is that a legitimate way of determining, oh yeah, now this is a new forensics tool that I can help figure out the stratification or the different, I shouldn't say stratification, wrong word. It's to see the knife to figure out, okay, this is the true knife the person has been stabbed with. Okay, it would be cool if that's possible, but again, lack of realism. So that's not realistic. So even if you did get some results, it's not reasonable to assume that those results could be a new forensics tool that law enforcement could use. No. Now I want to look at number 97. So take a minute and read it. So I want to know what the difference is between inference that can be done from a random sample versus random assignment. Okay, so in a study, remember, we have random sampling about and you can infer things about the population. But in random assignment, we can infer cause and effect. Because remember, random assignment means you've got volunteers, you're assigning them to a treatment, and considering that as a way of randomizing who gets what, yes, it's an experiment. An experiment allows cause and effect because we have a random assignment or random allocation. Okay, now go to number 98. So explaining the difference between types of inference that can usually be made of observational study and an experiment. Okay, so the bottom here is, remember, we can have a well-designed experiment, and that can infer cause and effect. But in an observational study, we have no cause and effect. So since we have no cause and effect, it is not applicable. So just because I see somebody and see them working out and say, oh, they're working out, so therefore they're sweating. Oh yeah, their metabolism building. They should be losing weight. Well, I'm just observing it. But if I was able to literally take their BMI, from the first day of the month, and then a week later, see how much their BMI has reduced. And keeping in mind, we've got to worry about our lurking variables. Okay, now that's a legitimate treatment, a well-designed treatment. But just saying, I see them working out, therefore they must be losing weight. Well, the reality is you have no basis to make that determination. So you've got to design an experiment. Now, we've talked about this before, the idea of ethics. Okay, what is the necessary criteria for determining cause and effect? It's got to be ethical treatment. You're not going to give a sugar pill to somebody that you know needs to have metformin, which is something for they're diabetic. So metformin's for diabetics. So you're going to say, oh yeah, well let's see if this medication is going to work for you. No. You don't give them a sugar pill. You don't give them a fake pill. Okay, which takes us to ethical difficulties. Well, you know how makeup companies many years ago used animals to test their products. That was an ethical difficulty. Our society was not going to stand for that. So with that being said, they had to start doing some simulations, or they started doing it on rats and mice that really truly somebody cares about, but I don't know who they are. But they no longer did it with the different rabbits, because they did them with rabbits for many, many years. Okay, so that's an ethical difficulty. Also, remember, the whole premise behind this is to do no harm. Okay, if you are going to, in many clinical trials, the whole goal is to see if this new medication is going to improve their health. Well, also, with that being said, it's medicine that you're ingesting, so that means it could also cause harm. So you've got to balance those things out to see if it's worthwhile to do this experiment, which takes me to the idea of data ethics. Okay, if you're going to do a situation like I mentioned, because like right now, if I came up with a medication that that cured cancer, which honestly that would be so amazing. In order to do that, it has to have some institutional review of the proposal. So in other words, I can't just say, oh yeah, Yarbrough Pharmaceuticals came up with this pill that cures cancer. You take it, and all of a sudden, whatever is going on, it will go away. Well, I've got to have a proposal to tell them why do I think it is. Okay, I've got to also, before they give it to humans, they've got to give it to animals. So it has to be reviewed to see if we're willing for the potential side effects that your pill might cause for humans. So, if it were only just simple as taking it and everything was, was amazing, the answer is no. Informed consent. Well, if you're going to have someone ingest something or do something to their physical body, they have got to basically say, yeah, I know this could be injurious to me, but I'm willing to basically take one for the team. I'm willing to be a part of this clinical trial because I know it's for the better good. And confidentiality. Confidentiality simply because you want to basically keep things secret, and you don't want one person in the group to tell someone else in the group, and then they start to think, well, you had this side effect, or it worked for you, so it must work for me too. So, and it's no one else's business except for you and the doctor or person administering the particular medication. It's no one else's business. So these are the data ethics that we've got to worry about or be concerned about, just to name a few. Okay, so let's go to number 100. And as we look at 100, the question is, what conclusion can be drawn from this study? So go ahead and read the study. Okay, so we see what's happening here, that we have a company. They've taken randomly selected 100 AA batteries, but the statistician randomly assigns, so here's your experiment, 50 batteries to be stored in the freezer and the other 50 to be room temperature. And at the end of the study, we found that each battery, they tested each battery. So the results was that it seemed like when it was in the freezer, okay, it was batteries stored in the freezer had a higher charge. That's what I was looking for. Okay, so explain. Now, here, this study did involve a random allocation to the treatment. So, given that's true, since we had 100, so we had enough replication. But here, we had random allocation of the treatment. One was refrigerated. One treatment was refrigeration. The other treatment was just room temperature. And they found out the refrigerated one was better. So yes, we can make inference about the entire population because it is large enough. And yes, there was a treatment imposed. Those are the two treatments: refrigerator versus the room temperature. Sorry, that was a serious delay. There was one more thing that I wanted to mention when it came to data ethics. If you turn to page 270 of your book, and we don't have room for it here, but when it came for data ethics, okay, we talked about do no harm. But what if I'm looking at where it says data ethics, and we have people trying to stop someone from drunk driving. So you have a television basically program that hires an actor to play a drunk driver and have a hidden camera. That reminds me of the show, What Would You Do? I think it comes on Channel 7. Now, is that ethical to do? Because first of all, are we testing to see if a person is going to get in the car? Okay, that's a reasonable experiment. But are we going to put a person in a car knowing that potentially the person is acting like a drunk driver? Okay, so at some point this tape stopped, and there's no way I'm starting this again, but I was referring to page 270. And this gives you an idea of, I like what the book did here, companies using discrimination, that finding out, the researcher prepares several resumes, and then we're seeing how that's going to, they're going to track the fake resume with the companies, and then keep track of the number of males and females that were contacted. Okay, you can see how that's unethical. Here, you're looking at the idea of the hidden driver. I think I mentioned that, but I'm not sure if it cut off. Okay, that's unethical. Promising for somebody to get a treatment, but you're giving them a sugar pill. I mentioned that idea to them. Okay, mentioned that idea to you. Okay, so data ethics, even though it's not a part of the AP test, is one of those things that is a very important part of statistics. Because experimental design is a part of statistics. So that's why I don't have a little component there for you to put down more data ethics stuff. But just read over this, keep in mind the overall idea of, we have to recognize if it's not ethical, then we're not going to do the design. So, TTFM, ta-ta for now. I will see you guys tomorrow. So go ahead and do whatever homework I've given you. Bye-bye.